L4th. 3. Obsolete carbon coal, squandering of resources with massive efficiency gains. C11. The bottom line. Plan B energy efficiency measures. From Plan October 2009. World electricity generation by source in 2008, and in the Plan B economy of 2020. Plan B carbon dioxide emissions reduction goals for 2020. Brown's expanded description. Re-establish a balance between carbon emissions and nature's capacity to sequester. Cutting net carbon dioxide, CO2, emissions 80% by 2020. This will halt the rise in atmospheric CO2, stabilizing it below 400 parts per million, ppm, up only modestly from the 384 ppm in 2007. Will also help keep future temperature rise to a minimum. Cut net CO2 emissions 80% by 2020. Includes stopping deforestation and an even more ambitious effort to cut fossil fuel use, raising energy efficiency to offset all projected demand growth, developing the Earth's rich array of renewable energy resources in order to close down all coal and oil-fired power plants. CO2 sequestration at coal-fired power plants. Extremely high costs. Lack of investor interest. Reassunted out that carbon sequestration will be economically viable on a meaningful scale by 2020. Nuclear power. We do not count on a build-up in nuclear power. Our assumption is that new openings of nuclear power plants worldwide will simply offset the closing of aging plants. If we use full cost pricing, requiring utilities to absorb the costs of disposing of nuclear waste, decommissioning the plant when it is worn out, insuring the reactors against possible accidents and terrorist attacks, then building nuclear plants in a competitive electricity market is simply not economical. World electricity generation totaled 18,500 gigawatts in 2006. 66% came from fossil fuels, 40% from coal, 6% from oil, and 20% from natural gas, 15% from nuclear, 16% from hydropower, 2% or so from other renewables. Average US home uses roughly 0.00001 gigawatt hours of electricity per year. Coal supplies 40% of the world's electricity, 70% of the electrical sector's CO2 emissions. First priority is to reduce demand enough to avoid constructing any new coal-fired power plants. Germany has cut coal use 37% since 1990. United Kingdom has cut coal use 43%, largely by replacing it with North Sea natural gas. Early 2007, some 150 new coal-fired plants were planned for US. Public opposition began to mount. California, which imports 20% of its electricity, prohibited the signing of any new contracts to import electricity produced with coal. Other states, including Florida, Texas, Minnesota, Washington, and Kansas, followed, refusing licenses for coal-fired power plants or otherwise preventing their construction. 2007 Citigroup downgraded coal company stocks. U.S. Senate Majority Leader Harry Reid of Nevada, who had been opposing 3 coal-fired power plants planned for his own state, announced that he was extending his opposition to building coal-fired power plants anywhere in the world. Investment analysts and political leaders are now beginning to see what has been obvious for some time to scientists such as NASA's James Hansen, who says that it makes no sense to build coal-fired power plants when we will have to bulldoze them in a few years. Banning the bulb. Perhaps the quickest, easiest, and most profitable way to reduce electricity use worldwide, thus cutting carbon emissions, is simply to change light bulbs. Replacing the inefficient incandescent light bulbs that are still widely used today with new compact fluorescents, CFLs, can reduce electricity use by 3/4. CFLs. Over its lifetime, each standard 13-watt CFL will reduce electricity bills by roughly $30. The energy saved by replacing a 100-watt incandescent bulb with an equivalent CFL over its lifetime is sufficient to drive a Toyota Prius hybrid car from New York to San Francisco. Each one reduces energy used by the equivalent of 200 pounds of coal over its lifetime. Action for CFLs worldwide. 2007, Australia announced it would phase out the sale of incandescent light bulbs by 2010. Canada soon followed, saying it would phase out incandescent sales by 2012. US coalition of environmental groups joined with Philips Lighting to launch an initiative to shift to more efficient bulbs in all of the country's estimated 4 billion light sockets by 2016. Action in US. By mid-2007, some 15 states either had passed or were considering legislation to restrict or ban the sale of incandescent light bulbs. The proposed legislation in New York, for example, would phase out incandescents by 2012. With a dozen or so others restricting or proposing to restrict use in one way or another, pressure is building to pass legislation making this shift nationwide. Note the 19th of December 11. Congress voted this week to delay national legislation mandating the switch to CFL''S. How could you allow this? Brazil. China action. Brazil, hit by a nationwide electricity shortage in 2002, responded with an ambitious program to replace incandescents with CFLs. An estimated half of its light sockets now contain these efficient bulbs. China, working with the Global Environment Facility, announced a plan to replace all its incandescents with more efficient lighting within a decade, 10 years. LED's even more efficient. CFLs use only 1/4, 25%, as much electricity as incandescent light bulbs. LEDs use 1/5 as much electricity as the old-fashioned incandescent bulbs, 20% less even than CFLs. New York City has replaced traditional bulbs with LEDs in many of its traffic lights, cutting its annual bill for maintenance and electricity by $6 million. LED costs are still high, however, discouraging widespread consumer use. Huge efficiency from turning lights off or down. There are numerous technologies for reducing electricity used for lighting, including motion sensors that turn lights off when spaces are unoccupied, such as in washrooms, hallways, and stairwells. In cities, dimmers can be used to reduce street light intensity, and timers can turn off outside lights that illuminate monuments or other landmarks when people are asleep. Dimmers can also be used to take advantage of daylighting to reduce the intensity of interior lighting. Save enough electricity to avoid building 705 coal-fired power plants, 30%. Shifting to CFLs in homes, to the most advanced linear fluorescence in office buildings, commercial outlets, and factories, and to LEDs in traffic lights would cut the world's share of electricity used for lighting from 19% to 7%. This would save enough electricity to avoid building 705 coal-fired power plants. By way of comparison, today there are 2,370 coal-fired plants in the world. Energy efficient appliances. Huge efficiencies exist for many household appliances, such as refrigerators. U.S. Energy Policy Act of 2005 can prevent 66 more plants, rise in efficiency standards, that will reduce electricity demand enough to avoid building 29 coal-fired power plants. Other provisions in the act, such as tax incentives that encourage the adoption of energy efficient technologies, a shift to more combined heat and power generation, and the adoption of real-time pricing of electricity, a measure that will discourage optional electricity use during peak demand periods, would cut electricity demand enough to avoid building an additional 37 coal-fired power plants. Altogether, these measures will reduce consumer electricity and gas bills in 2020 by over $20 billion. For every $1 invested in more efficient appliances, consumers will save over $4 on their electricity and gas bills. With appliance efficiency, the big challenge now is China. 1988's appliance manufacturers produced only 50,000 refrigerators, virtually all for domestic use. 2004 they produced 30 million refrigerators, 73 million color TVs, and 24 million clothes washers, many of which were for export. The extraordinary growth of industry raised China's electricity use sevenfold from 1980 to 2004. Europeans, on average, use roughly half as much electricity as Americans or Canadians. They still have a large potential for reducing their usage. Refrigerator in Europe uses roughly half as much electricity as one in the United States, 50%. The most efficient refrigerators on the market today use only 1/4 as much electricity as the average refrigerator in Europe, an 88% reduction vs US. Electricity for standby use, that consumed when the appliance is not being used, is up to 10% of total electricity consumption. Some governments are capping the amount of standby power used by TV sets, computers, microwaves, DVD players, and so on at 1 watt per appliance. South Korea, for example, is mandating a 1 watt limit on standby levels for many appliances by 2010. Australia is doing the same for nearly all appliances by 2012. A US study estimates that roughly 5% of US residential electricity use is consumed by appliances in standby mode. If this figure dropped to 1%, which could be done easily, it would reduce electricity use enough to avoid building 17 coal-fired power plants. Put appliance carbon costs at the sticker. The principal reason that consumers do not buy the most energy efficient appliances is because the improved design and insulation increase the upfront costs. If, however, societies adopt a carbon tax reflecting the healthcare costs of breathing polluted air and the costs of climate change, the more efficient appliances would be economically much more attractive. But also, it is a moral duty. Thou shalt not kill. Lighting and appliance efficiency could replace all new coal plants. A worldwide set of appliance efficiency standards keyed to the most efficient models on the market would lead to energy savings in the appliance sector approaching or exceeding the 12% of world electricity savings from more efficient lighting. Gains in lighting and appliance efficiencies alone would enable us to avoid building 1,410 coal-fired power plants more than the 1,382 new coal-fired power plants projected by the International Energy Agency, IEA, to be built by 2020. More efficient buildings. United States. Buildings commercial and residential account for 70% of electricity use and over 38% of CO2 emissions worldwide. Building construction accounts for 40% of materials use. An energy retrofit of an older inefficient building can cut energy use by 20 to 50%. The next step, shifting entirely to carbon-free electricity, either generated on-site or purchased, to heat, cool, and light the building completes the job. Presto. A zero-carbon building. Recognizing the value of green buildings. Growing sense of the looming obsolete sense of non-green buildings, one that is driving a wave of reform in both construction and real estate. Further, Davis Langdon says, going green is future-proofing your asset. Leadership in Energy and Environmental Design, LEED. Voluntary certification program, sets standards so high that it has eclipsed the US government Energy Star certification program for buildings. 4 certification levels certified, silver, gold, and platinum, are attractive to buyers because they have lower operating costs, higher lease rates, and happier, healthier occupants than traditional buildings do. LEED gives insight into the many ways buildings can become more energy efficient. Site selection, locating the building close to public transport, such as light rail or buses. Energy efficiency, including must maximize the exposure to daylight, with minimum daylight illumination for 75% of the occupied space. Water efficiency, materials used, and indoor environmental quality. Higher certification depends on provision of bicycle racks and shower facilities for employees. LEED. With energy exceeding the high level of efficiency required for basic certification earns additional points. Further points are awarded for the use of renewable energy, including rooftop solar cells to generate electricity, rooftop solar water and space heaters, and the purchase of green power. LEED. Chesapeake Bay Foundation's office building for its 100 staff members near Annapolis, Maryland, ground source heat pump for heating and cooling, a rooftop solar heater for hot water, and sleekly designed composting toilets that produce a rich humus used to fertilize the landscape surrounding the building. Toyota's North American office in Torrance, California, houses 2,000 employees. Large solar electric generating facility. The combination of waterless urinals and rainwater recycling enable it to operate with 94% less water than a conventionally designed building of the same size. LEED. 54-story Bank of America Tower in New York, its own cogeneration power plant, and will collect rainwater, reuse wastewater, and use recycled materials in construction. New buildings at the World Trade Center site is being designed to achieve gold certification. 60-story office building in Chicago, use river water to cool the building in summer. And the rooftop will be covered with plants to reduce runoff and heat loss. Energy conserving measures will save the owner $800,000 a year in energy bills. California study of LEED buildings. Certification raised construction costs by $4 per square foot. The standard and silver certified buildings earned a profit over the first 20 years of $49 per square foot. The gold and platinum certified buildings earned $67 per square foot. Architects. Today's architectural concepts and construction technologies enable architects to easily design new buildings with half the energy requirements of today's buildings. Among the design technologies are natural daylighting, rooftop solar electric cells, natural ventilation, glazed windows, reduced water use, more efficient lighting technologies, and motion sensors for lighting. Restructuring the transport system. Compelling reasons for countries everywhere to restructure their transport systems, stabilize atmospheric CO2 levels, prepare for falling oil production, alleviate traffic congestion, reduce air pollution. The US car-centered transportation model, with 3 cars for every 4 people, will not likely be viable over the long term even for the United States. Reshaping transportation systems centers around changing role of the car. Transition from a predominantly rural global society to a largely urban one. By 2020 close to 55% of us will be living in cities, where the role of cars is diminishing. In Europe, where this process is well along, car sales in almost every country have peaked and are falling. World oil output close to peaking. Will not be enough economically recoverable oil. Oil shocks are now a major security risk. US, where 88% of the 133 million working people travels to work by car, is dangerously vulnerable. World policy emerging in places. London, a daily $16 toll on cars entering central London. Possibly a $50 per day charge on sport utility vehicles entering the city because of their high CO2 emissions. Proposal enjoys the support of Londoners by a 3-to-1 margin. New York, considering a tax on cars entering the city. World policy emerging in places. New York and San Francisco, taxes in their cities will be hybrids by 2012. New York goal is to replace the 13,000 existing taxis that get roughly 14 miles per gallon with cars that will get 30 to 50 miles per gallon, or 3 times improvement. Reduce CO2 emissions, fuel use, and local air pollution. Future of city transportation. In city, lies with a mix of light rail, buses, bicycles, cars, and walking. Intra-city, over distances of 500 miles or less belongs to high-speed trains. operating at speeds up to 190 miles per hour. Japan's bullet trains carry almost 1 million passengers a day. On some of the heavily used intercity high-speed rail lines, trains depart every 3 minutes. Japan's high-speed rail network now stretches for 1,360 miles, linking nearly all its major cities. European high-speed rail. Early 2007 there were 3,034 miles of high-speed rail operating in Europe, 1,711 more miles, to be added by 2010. The Paris to Brussels link, a distance of 194 miles, that is covered by train in 85 minutes. When it opened, the share of those traveling between the two cities by train rose from 24% to 50%, 2 times. The car share dropped from 61% to 43%, a 30% reduction, and CO2 intensive plane travel virtually disappeared. Carbon dioxide emissions per passenger mile on Europe's high-speed trains are 1/3 those of its cars and only 1/4 those of its planes. High-speed rail. In the Plan B economy, CO2 emissions from trains will essentially be zero, since they will be powered by green electricity. In addition to being comfortable and convenient, these rail links reduce air pollution, congestion, noise, and accidents. They also free travelers from the frustrations of traffic congestion and long airport security check lines. The Economist notes, Europe is in the grip of a high-speed rail revolution. US. There is a parallel need to develop an electrified national rail freight network that would greatly reduce the need for long-haul trucks. Any meaningful global effort to cut transport CO2 emissions begins with the United States, which consumes more gasoline than the next 20 countries combined, including Japan, China, Russia, Germany, and Brazil. The United States with 238 million vehicles out of the global 860 million, or roughly 28% of the world total, not only has the largest automobile fleet, but is near the top in miles driven per car, and near the bottom in fuel efficiency. 3 initiatives are needed in the US. 1. Is putting the cost of the carbon in the pump price, phasing in a gasoline tax of 40 cents per gallon per year for the next 12 years, for a total rise of $4.80 a gallon, and offsetting it with a reduction in income taxes would raise the US gasoline tax to the $4.5 per gallon prevailing today in Europe and Japan too. Raising the fuel efficiency standard from the 22 miles per gallon of cars sold in 2006 to 45 miles per gallon by 2020. Reaching our CO2 reduction goal depends on a heavy shift of transportation funds from highway construction to urban transit and intercity rail construction. A new materials economy. The production, processing, and disposal of material in our modern throwaway economy wastes not only material but energy as well. In nature, one-way linear flows do not survive long. The throwaway economy that has been evolving over the last half-century is an aberration, now itself headed for the junk heap of history. Potential for sharply reducing materials use. Pioneered in Germany in the early 1990s. Then Schmid-Bleek, who founded the Factor 10 Institute in France, showed that raising resource productivity even more by a factor of 10 was well within the reach of existing technology and management, given the right policy incentives. In 2002, American architect William McDonough and German chemist Michael Braungart co-authored Cradle to Cradle, Remaking the Way We Make Things. They concluded that waste and pollution are to be avoided entirely. Pollution, said McDonough, is a symbol of design failure. Industry is more than 30% of world energy consumption, including the production of plastics, fertilizers, steel, cement, and paper. Petrochemical industry, which produces products such as plastics, fertilizers, and detergents, is the biggest consumer of energy in the manufacturing sector, accounting for about 1/3 of worldwide industrial energy use, 10% of total energy use. A large part of industry fossil fuel use is for feedstock, to manufacture plastics and other materials. Increased recycling can reduce feedstock needs. worldwide, increasing recycling rates, and moving to the most efficient manufacturing systems in use today could reduce energy use in the petrochemical industry by 32%, 3% world total. Global steel industry second largest consumer of industrial energy, producing over 1.2 billion tons in 2006, accounting for 19% of industrial energy use, 6% of world total. Energy efficiency measures, such as adopting the most efficient blast furnace systems in use today, and the complete recovery of used steel, could reduce energy use in the steel industry by 23%, about 1.5% of world total. Recycling steel. Reducing materials use means recycling steel, the use of which dwarfs that of all other metals combined. Steel use is dominated by three industries: automobile, household appliances, and construction. Steel recycling rates. In the United States, virtually all cars are recycled, effectively 100%. US recycling rate for household appliances is estimated at 90%. Steel cans it is 60%. Construction steel it is 97% for steel beams and girders, only 65% for reinforcement steel. The steel discarded each year is enough to meet the needs of the US automobile industry. Electric arc furnace. Steel recycling started climbing more than a generation ago with the advent of the electric arc furnace. Produces steel from scrap using only 1/4 the energy it would take to produce it from virgin ore, 75% reduction. Now account for half or more of steel production in more than 20 countries, 50%. If 3/4 of steel production were to switch to electric arc furnaces using scrap, energy use in the steel industry could be cut by almost 40%, about 2.4% world total. Cement industry. Turning out 2.3 billion tons in 2006. Accounting for 7% of industrial energy use. China, close to half of world production, 50%, manufactures more cement than the next top 20 countries combined. Does so with extraordinary inefficiency. With modern technology could reduce its energy consumption for cement production by 45%. Worldwide, if all cement producers used the most efficient dry kiln process in use today, energy use in the cement industry could drop 42%, about 2.9% world total. Restructuring transportation impacts material use. Improving urban transit means that one 12-ton bus can replace 60 cars weighing 1.5 tons each, or 90 tons, a 87% reduction in weight and steel use. Every time someone decides to replace a car with a bike, material use is reduced by 99%. Recycling use is a fraction of energy vs raw materials. Virtually all paper products can now be recycled, including cereal boxes, junk mail, and paper bags in addition to newspapers and magazines. So too can glass, most plastics, aluminum, and other materials from buildings being torn down. Metals such as steel and aluminum can be used and reused indefinitely. Advanced economies such as Europe and Japan can rely primarily on the stock of materials already in the economy, rather than using virgin raw materials. Recycling. Metals such as steel and aluminum can be used and reused indefinitely. To encourage recycling, adopt a landfill tax. New Hampshire adopted a pay-as-you-throw program. In one NH town, a landfill tax raised the share of garbage recycled from 13% in 2005 to 52% in 2006, a 4 times increase. Recycling. San Jose, California diverting 62% of its municipal waste from landfills for reuse and recycling, now focusing on the large flow of trash from construction and demolition sites. One of 24 specialist recycling firms in the city, skillfully separated into recyclable piles of concrete, scrap metal, wood, and plastics, from only about 100,000 tons per year to 500,000 tons of the city's mixed construction and demolition materials, a 5 times increase. By deconstructing a building instead of simply demolishing it, most of the material in it can be reused or recycled, thus dramatically reducing energy use, materials, and carbon emissions. Designed for easy disassembly and recycling. 1998 Japan law prohibits discarding household appliances, such as washing machines, TV sets, or air conditioners. With consumers bearing the cost of disassembling appliances in the form of a disposal fee to recycling firms, which can come to $60 for a refrigerator or $35 for a washing machine. The pressure to design appliances so they can be more easily and cheaply disassembled is strong. Remanufacturing. Caterpillar has emerged as a leader. Recycles some 17 truckloads of diesel engines a day at one plant. Disassembled by hand by workers who do not throw away a single component. Reassembled with all worn parts repaired. Remanufacturing division is racking up $1 billion a year in sales and growing at 15% annually. Airliner recycling. Boeing and Airbus now vying to see who can dismantle them most efficiently. First step is to strip the plane of its marketable components, such as engines, landing gear, galley ovens, and hundreds of other items. Up to $4 million per jet. Final dismantling and recycling of aluminum, copper, plastic, and other materials. The goal is to recycle 90% of the plane, and perhaps one day 95% or more. More than 3,000 airliners already put out to pasture, and more coming. An aluminum mine. Computers. Becoming obsolete every few years. Need to be able to quickly disassemble and recycle them. European law requires that manufacturers pay for the collection, disassembly and recycling of toxic materials. IT equipment. Manufacturers have begun to focus on how to disassemble everything from computers to cell phones. Recycled clothing. Patagonia is now recycling not only the polyester garments it sells, but also those that are sold by its competitors. Patagonia estimates that a garment made from recycled polyester, which is indistinguishable from the initial polyester made from petroleum, uses less than 1/4 as much energy, a 75% reduction. Patagonia is beginning to work on nylon garments and plans also to recycle cotton and wool clothing. Reuse of products. Finland, for example, has banned the use of one-way soft drink containers. Canada's Prince Edward Island has adopted a similar ban on all non-refillable beverage containers. A refillable glass bottle used over and over requires about 10% as much energy per use as an aluminum can that is recycled. Cleaning, sterilizing, and relabeling a used bottle requires little energy compared with recycling cans made from aluminum. Banning non-refillables is a quintuple win option, cutting material use, carbon emissions, air pollution, water pollution, and garbage flow to landfills. Discourage energy-intensive non-essential industries. The gold and bottled water industries are prime examples. Processing 500 million tons of ore consumes a huge amount of energy and emits as much CO2 as 5.5 million cars. In the United States and Europe there are more standards regulating the quality of tap water than of bottled water. For people in developing countries, where water is unsafe, it is far cheaper to boil or filter water than to buy it in bottles. Bottled water. Nearly 28 billion plastic bottles used to package water in the United States alone. Requires 17 million barrels of oil, including the energy for hauling 1 billion bottles of water every 2 weeks from bottling plants to supermarkets or convenience stores for sale. US bottled water industry consumes roughly 50 million barrels of oil per year. Costs 1,000 times as much as the tap water that is already available in city buildings. Vast opportunity for carbon reduction through reduced materials use. This begins with the major metals steel, aluminum, and copper. Recycling requires only a fraction of the energy. It continues with the design of cars, household appliances, and other products, so they are easily disassembled into their component parts for reuse or recycling. The energy savings potential is vast. Plan B. Energy efficiency measures. Put the carbon price in the product price. One easy way to achieve these gains is through the imposition of a carbon tax that would help reflect the full cost of burning fossil fuels. We recommend increasing the carbon tax by $20 per ton each year over the next 12 years, for a total of $240. It does not come close to covering the indirect costs of burning fossil fuels. World electricity generation by source in 2008, and in the Plan B economy of 2020. Plan B carbon dioxide emissions reduction goals for 2020.